everyone, welcome to this video about how to use the exponent rules. So I believe that everything in life is a lot easier when we love ourselves, including math. So one of the things that can help make your math really easy is realizing that when you make a mistake, your brain is actually growing. So making mistakes is not a bad thing, it's just an opportunity for you to learn. And your brain actually physically grows more brain mass because it starts making new connections when you make a mistake and then learn how to fix your mistake. So just keep that in mind, and maybe that will help you give yourself a little bit of self-love as you're learning and developing your math skills. So think about that. Take 2 deep breaths and give yourself a little bit of love, and then let's make this math easy. Okay, so when you're working with exponent rules, the first thing you want to do is make sure that you understand how each of the individual rules work on their own. So if you haven't watched my other videos about each of these exponent rules, I would recommend watching those first. The links are below this video. And then after you've watched how each of the individual exponent rules works, then you can come back to this video and see how they work when you put them all together. And the one thing that you want to remember about exponent rules is that they can go in reverse order as well. So like the distributive property, for example, takes two numbers that are multiplied together inside of parentheses. And if it's raised to an exponent, the distributive property says that you can take that exponent and distribute it to the two things inside of the parentheses, which would look like that. However, you can also use the reverse distributive property if it's helpful. So if you have a situation where you have two numbers being multiplied together and they have the same exponent, you can use the reverse distributive property of exponents to go back to the form with the parentheses. It just depends on whatever is going to be the most useful for the situation you're working with. So when you're using the exponent rules, the general guide that you want to follow is you want to look at the expression that you're given and then choose the matching exponent rule. So if you notice something where you've got two things with the same base being multiplied, then you could say, oh, that looks like a product rule thing. And so you'd choose the product rule, and then you'd convert the expression by adding the exponents together. And sometimes you may have to use more than one exponent rule to simplify something. For example, in this example, when you look at the form that you're given, you notice that you have some things being multiplied inside of parentheses, including an x to the third, which has an exponent with it. And then you notice that outside of the parentheses, you have a power. And so when you look at that, you can see that it looks kind of like the distributive property of exponents, and it also looks kind of like the power rule of exponents. But the first thing you would want to start with is the distributive property, because the power rule doesn't account for the 7 out here. So the way that you would approach this is you'd say, okay, well, I have two things being multiplied, the 7 and the x cubed, and those are being raised to the second power. So the distributive property of exponents says that I can distribute the 2, or the squared, to both parts. So I'd say, okay, well, according to the distributive property of exponents, that gives me 7 squared and x cubed squared. So this x cubed as a whole thing is being squared. And then from there, I could simplify it and I could say, well, 7 squared is just 49. And according to the power rule, because this is a power rule situation where you've got a power to another power, that means that I can multiply those two exponents together, which would give me x to the 6th. So this entire problem could be simplified to be 49 x to the 6th, because the distributive property allowed me to distribute the 2, and then the power rule allowed me to change x to the 3rd squared into x to the 6th. And so this would be the most simplified form of that expression. If I had something like this, I would look through all of my different rules, and it looks like the rule that this matches with the most is the quotient rule. So I would follow the quotient rule, and I would say, okay, if I have a number raised to a power divided by the same number raised to another power, then I can subtract the two exponents to simplify it. So I could say, okay, x squared, or if I do 2 minus 5, because I can subtract the exponents, that would give me x to the negative 3, because 2 minus 5 is negative 3. And then that tells me that I need to use the negative exponent rule, because x to the negative 3 is equal to 1 over x cubed. And so this would be my fully simplified answer. Sometimes you could also use this one. It just depends on how the problem, like whatever problem you're working on, if they are okay with you having negative exponents, then you could just do it like that. But if they ask you to do it with only positive exponents, then you would use the negative exponent rule to put it into that form. If you were to do a problem like this one, where you have x to the third times x to the 1/2, the first thing you would want to notice is the fact that it looks like the product rule, because you have something being raised to a power, and then you have the same something. That's important with the product rule, is that the bases are the same, and that's being raised to a fraction. And so the product rule says that you can add the fractions, or add the exponents together. Now, if I'm going to add 3 and 1/2, I have to make sure that I follow the rules for adding a whole number to a fraction. So over here on the side, I'm going to think about this and be like, okay, if I'm trying to do 3 plus 1/2, I have to have common denominators. So 3 in terms of halves is 6 halves, because 6 halves is the same thing as 3 wholes. So I could change the 3 to have the common denominator, and if I do 6 halves plus 1/2, that's going to equal 7 halves. So this expression can be rewritten as x to the 7 halves power. Then if my answer doesn't, like if they don't want it to be in fraction form, I could use the fractional exponent rule to write it as a root. So I could say, okay, the top number just works like a normal exponent, so I could write that as x to the 7. And then the bottom number tells me what type of root it is. So I could do the square root of x to the 7, and this would be the fully simplified form of this problem. But again, some problems will, depending on your math book or the way that your teacher asks you to answer the problem, sometimes this will also be allowed. It just depends on if they are okay with you having fractional exponents, or if they want you to put it in radical form, which means that you're like putting it inside of a root. So that's how you would solve a problem like that. If you have a problem like this one, you could choose to do it in two different ways. You could use the reverse distributive property of exponents and do that, or you could do the exponent of 0 and do that. So I'm going to start off with the reverse distributive property of exponents first. And the reason why I'm doing that is because this problem is in this form, where you've got two things with the same exponent but different bases. And that means that I can simplify it by putting kind of like undistributing the 0 and writing that as 6 over 2 to the 0 power, which I can simplify because 6 over 2 is 3, so that would give me 3 to the 0 power. And then I could use the exponent of 0 rule to say that that equals 1, because anything to the 0 power equals 1. Now another way I could have done this, I'll write this in a different color, is I could have simplified it using the exponent of 0 right off the bat. So if I have 6 to the 0 over 2 to the 0, anything to the 0 power is just 1. So I could have written it as 1 over 1, and that would just equal 1. So either way, you end up getting the same answer, but you can use the exponent rules however it would be most easy for you to do. So again, to summarize, the way that you use the exponent rules is you want to identify the form of the given equation, and there may be more than one form. Like all of these examples I gave you had 2 forms, but you could have even like 3 or 4 forms, depending on how complex the expression is. But identify the form of the given equation, choose the exponent rule that it goes with that, and then convert the expression to the alternative form and simplify it that way. And that's how you can use the exponent rules.
I hope this video was helpful for you. To learn more about the individual exponent rules, click on the links below and then subscribe and let me know in the comments how easy this topic was for you. For more help with exponents in general, check out my Exponents playlist here on YouTube or go to mathtutoringonline.com to get additional help by asking a question or booking a one-on-one tutoring session. See you soon!